Okay, guys, welcome to the second class. Look, this is your V1, V2, V1 plus V3, and we have to solve another question, another equation, so that we can get it as a form of V1 equal to V3. Okay, that is your first equation was V2, second nodal analysis. I am directly writing this 5 plus it was. Remember the second equation was the initial point. Look, in your second node, there is another equation was V2 minus V1 divided by 3 plus this V2 by 5 plus V2 minus 10 divided by 1 equal to 0. It was the second node. Second node. Okay. So if there is a equation, then we can easily solve another equation so that V2 by 3 minus V1 by 3 plus V2 by 5 plus this is 1. So this is V2 and this is minus 10. Okay, that is 0. And we get minus V1 by 3. This is, and this plus is coming over here. So 1 by 3 plus 1 by 5 plus 1 equal to 0. And from this we can get, it V2 plus 3 plus 15 divided by this 15 minus V1 by 3, that is 10. So V2 23 by 15 in minus V1 by 3 equal to 10, or we can say directly 4 point, sorry, this is coming 4.6. 4.6 V2 minus V1 equal to 30 because this 3 is coming over here. So we can write V1 equal to 4.6 V2 because here is coming and it is coming over here. So it is minus 30. So this is also an equation. That is also a equation number 3. Sorry, here is V2. Okay, that is equation number 3. So how many equation we got? So here is V1, V2, and another is this equation. Just write down over here. V1 equal to 46 V2 minus 30. So you can see here is an equation. The both equation is there where V1 and V2 is present. Here is also V1 and V2 is present. So if I going for the summation, then any of one may be reduced. So we can get only exact value of V1 or the V2. But in the second equation, you can find there is the V1 and V3 also. So if I can find out the value of V1, then we can put over here. So we can get also the value of the V3. This is the equation, salvage beauty of this equation. Okay, so we can put it, we can just put it over here. So this is the equation number 3. If I put this V1 value, if I put this V1 value over here, then what will you get? Only V2. So just do it. Look, write down here 15 equal to 1.3 V1 minus V2. Just put this V1 value. Here is the equation 2, equation 3. Put the value of equation 3. Putting the value of putting the value of V1 by the by here. So what we will get? We will get, just look, this is 15 volt equal to 1.3 into, that is 4.6 V2 minus 30, sorry, minus 30. Okay, equal to minus V2. I just put the value of V1. So what we will get? Just 1.3 multiplied with 4.6. It will coming near about 5.98. Okay, V2. Okay, and this is 1.3 multiplied with the 30. It will coming 39. 13 into 3 equal to, it is coming 39, and 0 then decimal is opt out. So we get minus V2. Here is 15. So from this just this, look, here we get also this value. So it is coming over here 15, uh, 15, and this is 39. So it will coming near about 4 5 4. It is, and if you do this minus, then it is coming in 4.98 V2. So you can just V2 is the V2 is the 54 divided by 4.98. What will it come? It is coming near about 10.84 volt. Okay. So this is V2 value, exact value of V2. After so many equations, solving of so many equation, you get this value. And you can easily put the value over here. If you put the value of V2, then you will get the V1. Okay. So V1 equal to, so V1 equal to, what is V1 equal to, just put it 46 into 10, value of the V2, that is 84 plus 30, it is coming 49.8x4 minus 30 equal to 19.864, means it is coming 19.86. Okay, so V1 value, you get V2 value and V1 value. Just write down over here. V1 equal to 19.86, V2 equal to 10.84. 10.84. Okay, now we have to collect this V3. What is the V3? Okay, V3 was 10. You know this is V3 was uh, V3 over there in this circuit. So no need of V3, no need of, not required. So I have to find out what is, I have to I1, I2, I3, and I4 and I5. So I1 is what? I1 is 5 ampere. It was previously given. Then what is the I2? I2 is the V1 by 10. So V1 by 10, V1 by 10 means 19.86. So divided by 10 means 1.986. So it is coming 1.986, means it is V1 by 10. Okay. So it is coming this. Now I3, what is the I3? Find out this I3. What is the value of the I3? I3 is the value of V1 minus V2. So V1 is the 19.86, V2 is here, V2 is here 10.84 divided by, what is the I3 divided by, this is the 3 ohm. So this is divided by 3. So it will generally coming in 3.3.00. Use your calculator. It may be something wrong, then you can correct it, because I am doing with me. So it is coming 3 ampere. Here is, it is coming, that is ampere. You can terminate with 1.99 ampere. Okay, this is 3 ampere. I3 is 3 ampere. Now we can find the I4. What is the I4? I4 is, just look. What is the I4? Just watch the equation. Just remember the circuit. Here is circuit is not I4 is the V2 by V0, V2 by V0, V2 by V0 means reference node divided by this 5 ampere. So only this is 0. So V2 is, what is V2? V2 is 10.84 divided by 5. So it is coming 2.168 ampere. Okay. Now I have to find the I5. What is the I5? I5, look, V2 minus this 10 volt, where here is the 10 volt is there, 10 volt is there, and it is coming over here, that is V2. So V2 minus 10 volt divided by this resistance was 1. So this is 1 by, so we easily can find out 10 by 84 divided by 10, summation, subtraction of 10, it is coming 0.84 ampere. So this is your equation. So we can write what are our equation. I1 is, what is I1 is 5, I1 is 5, I2 is 1.99 ampere, and I3 is what is I3? I3 is 3 ampere, and I4 is 2.16 ampere, and I5 is 0.084 or ampere. So this is your answer. Guys, if you get any difficulties or any question, you may ask me. So something, you get some long equation and you have to use this, but look, this is a very easy step. Only simple mathematical summation, multiplication and subtractions is there. No integration, no derivation, no special expression is required for this type of solution, but a long process is there. So this is your nodal analysis. And if you have any question, you may ask me. Otherwise, I am going for the superposition theorem. Okay, I'm going for the superposition theorem. Okay, the next topic is superposition theorem. Okay, first we have to know the statement. What is superposition theorem? So if a number of voltage or current source are acting simultaneously linear network the resultant TANT resultant current in any branch is the algebraic of the currents Okay, if a number of voltage or the current source are acting simultaneously in a linear network, or not only linear, it will be, you can say, linear bilateral network, the resultant current in any branch is the algebraic sum of the currents that would be produced in it when each source acts alone, replacing all other independent source by their internal resistance. What does it mean? Say, here is your circuit is there, here is your circuit is there. So if it is a current source, I am assuming this, it is a voltage source is there. So if I want to know a current flowing through this branch, okay, so this is X, this is Y, this is X ohm, this is Y ohm, this is Z ohm. Okay, Z ohm. So what does it want means? Means when only each source is present. So you have to find out only only this voltage source is present and nothing is there, means only this voltage is there. Then if there is a I1 and if internal resistance, okay, and if it is there, then sorry, this current source, it will be open, okay, and if it is voltage source, then it is shorted. Then what will be the current? Say that is the I2. So IZ equal to the I1 plus I2. This is the equation. This is the solution. So again, we have to understand this. If a number of voltage or current source are acting simultaneously, look, this voltage source, this current source are acting simultaneously. Yes, this in a linear network means all components are in generally the resistance. But if there is something non-linear components means this type of or this type of means uh, inductance or capacitance is there, then it may not be uh, applicable. Or sometimes say this is a this type of elements are there, then it will not work, not follow the superposition theorem. Okay, so linear network, the resultant current in any branch. Say this is the resultant current IZ. Say this is the IZ current is flowing because it is working. It is also working. So what will be the net current? This net current is the algebraic sum of the current that would be produced in it. Algebraic sum means something. Algebraic sum means different current when each source acts alone. Uh, uh, acts alone means this source is only acting and replacing all other independent sources by their internal resistance. Okay, this is the this is the problem and this is the statement. Now if you can understand this, means if this voltage source is acting, then current source will not there. If current source is there, voltage source will be not there. And then what will be the current? Yes, this is current I1 and I2. So total current will be, net current will be IZ equal to I1 plus I2. This is the statements of superposition theorem. Now we have to solve it with an example. Now first we have to go for the steps. How could I solve this? Now this is steps for of a network to consider only one independent source of the voltage or the current and deactivating the other independent voltage or the current source. So if there is a two, say there is there, then first solve it. Once upon a time you have to take this here, and sometimes we have to take this. Okay, so one time you have to replace another sources. For each source you have to find out the current. Okay, then step 2. Acha, another declaration is there, not step 2 is there. Just short circuit the respective if circuit terminal. So here it will be another. So if this is a voltage source, then we have to short circuit. Okay, if for the current source, just remember this. For current source, so here it will be not short circuit. So if you want to replace the current source, then you have to put open. But if you want to replace the voltage source, then you have to short. Okay, this is short, short. This is open. Okay. Now that is step two. Step two. Replace the above. Sorry, not replace. This is repeat. The above step for each of the independent source. CS. Okay. Step one and step two for each branch. So if say this is for the two source, so you have to find replace one current source and another 10 voltage source. If there is a three sources there, then you have to put this equation for the three sources. First is the one, you have to replace it, then two replace it, then three replace it. One by one you can get. Then you get I1, I2, I3. So you have to then after then you have to get the summation. Then you can get the total current where your three sources are acting simultaneously. If there is a number of four, then you have to perform it again this process for the number of four. Okay, so let's see another example so you can understand. Look, look, here is your, okay, this is a, okay, this is 10 ohm, this is 20 ohm, this is this is 2 ohm, this is 2 ohm, this is 3 ohm, this is 5 ohm. Now this is plus, this is minus. Okay guys, I am just giving you this example so that uh, as a you can solve it in your own hand. Maybe time is very less, it is showing some. Okay, so the question is there, find the voltage and current across the 2 ohm RESIS resistor, 2 ohm resistor by using the superposition theorem. Okay, so using superposition theorem, we have to find out the voltage and current. Okay, so what will be the steps? Uh, First, we have determined the steps. First, we have to take only voltage source current for, that is current for 2 ohm resistance, that is for the 10 volt source current for, this is 1, 2 ohm resistance, this is 2, for the 2 ampere source current for 2 ohm resistance for 3, that is for 20 volt resistance. Then we have to find out it, whenever we're going to find out this voltage source is remain and these two will be out, but in case of the current source it will be open, in case of the voltage source it will be short. Then we have to find out again I2 current source for the 2 ampere. Look, this is the 2 ampere. So you have to find out this 2 ampere, then it will be replaced. It will be replaced. Only these things will be remain. So we can find out the I2. And whenever we are using for the 20 volt source, then this will be there and it will be replaced, and only then we can find this current. And after then we have to summation of I1, I2 and I3, then we can get the overall current. This is the superposition theorem, but this is your home task. Only few minutes is there, that's why it is not possible for us for today, and next day I will solve it. And guys, if you have any question you may ask me. Just solve it one by one. Maybe one or two steps today we can follow. Say step one, that is step one for 10 volt source. So draw this diagram. This is 5, this is 1, this is here. But as it is a current source, you have to keep open. So this is the 5, but this terminal you have to replace it, but this terminal should be short, as this is a voltage source. Voltage source. If this voltage source have any resistance, then you have to put this. Say if this voltage source has 2 ohm resistance, then you have to put this 2 ohm resistance. But this is the current source. You have to just open it. So what will be the circuit? This is 10 ohm. This is 10 ohm. This is 20 ohm, and this is 2 ohm resistance. This is 3 ohm resistance. This is 5 ohm resistance. But you can see in this 3 ohm resistance, this branch, it will no current will can flow because this is circuit is open. So only the ultimate circuit is coming. Ultimate circuit is coming. Look, this is minus, this is ultimate circuit is coming 5, and this is short. So this is 2, this is 5, this is 20, this is 10. No circuit, you can see this is very easy circuit it became. So you can find it just like this. 10, this is 20, and this is 7 ohm. This is 7 ohm, this is 10 ohm, this is 10 volt. So you have to find, you can put any KCL, say that is I1, that is I2, and this is I3. I3 you can put for the KCL. So I3 is current is flowing for the 10 volt sources. In this way, for the step 2, you have to find out this what is the I3 current over here for the 10 volt. Step 3, look, this it will be I first it will be short. Okay, then 10, then 20. This branch is there. Say I am keeping this 5 3. Sorry, here is no resistance was there. Just I forget. 5 5. Here is 3. Here is 2. Here is 20. 10. Now this is also a voltage source. So you have to replace it. But whenever voltage source is there, you have to short and it will be removed. So it will be your circuit. This is your circuit for the step 3. And for the next step, for the say this type of resistance, so at that moment it will be removed, it will be again removed, it will be open, and it will be short for the, so it will be short. Okay, it will open. So you can find here this time of I3 for the 20 volt. Then we can add this, then we can get what is the ultimate current, and then we can put down this total current into this resistance 2. This resistance 2 we can get the voltage. In this way we can solve this superposition, and next day I will solve it because only 1 minute is left. So guys, today we can I think I should stop here, and if you have any queries then you may ask me. Okay guys, now I'm going to stop here because lots of equation will require minimum 1 hour. Then tomorrow I will solve it, and do it in your own hand. This is very simple math. Just put the KCL, then just sum it. Okay, so I'm stop here. Thank you. Thank you. Have a nice